Now we will discuss here the step-by-step process of calculating the principal components. So these are the 5 main steps that we need to follow for calculating the principal components and to reduce the original data into the reduced set of dimensions. So first step is standardization of the data. That is one of the important step in any machine learning task, right? Then computing the covariance matrix. Then the third step is calculating the eigenvectors and eigenvalues from this covariance matrix. Then after calculating these eigenvectors and eigenvalues, then we need to compute the principal components, right? Then after calculating this principal component, we reduce the dimensions of the data with the help of these principal components. So in detail, we can discuss here how this each and every steps work, right? So in the previous session already, we have discussed this standardization techniques, right? Which is one of the pre-processing techniques in any machine learning model, right? So as you know, the importance of standardization techniques, right? Standardization is all about scaling your data in such a way that all the variables and their values lie within a similar range. All the values after standardization process, all the values lie within a similar range. If you observe here in the example, there are two variables, rating and number of downloads, right? So here rating feature between only 0.5, right? 0 to 5 only. The values are between 0 to 5, that is with the very less range of values, right? And the number of download range is between the 100 to 5,000, which is very high range. So when my data set contains the very low range values and high range values overpower the low range values. Means what? When we use these values as it is in the machine learning model, and if, for example, if you want to find out the cluster and similarity between the object, only the high range value gives the more contribution for classifying the model as compared to the less range values, right? And that's why it becomes necessary to convert these data set into the similar range, for example 0 to 1 or -1 to 1. So already you know different standardization techniques. One of this standardization technique is a z-score normalization technique, right? The formula for z-score normalization is what? Your original value of the variable minus mean divided by the standard deviation. So you can use this formula to convert all these values into the similar range, right? I hope student you are clear with this. Then after this standardization of the data, you can use the second step, right? Computing the covariance matrix, right? The mathematics of this covariance matrix already we have covered in the previous session. If there are two dimensions in the data set, your covariance matrix will be of the dimension 2 by 2, right? Your covariance matrix will be of 2 by 2 dimension. Then here the covariance matrix actually expresses the correlation between the different variables in the data set. It is essential to identify heavily dependent variables because they contain biased and redundant information, which reduces the overall performance of the model. As we discussed the example of age and date of birth, both are highly correlated and both are providing the same information. We can say these are the redundant data in the data set, and with the help of covariance matrix you can find this highly correlated variable. Those are of both are not important in the data set, one you can reduce from the data set, right? So covariance matrix will help you to find this highly correlated variables that we can remove from the data set, and also high variance features, right? Those provide the more information for your model, right? Then after finding the covariance matrix, we can calculate the eigenvectors and eigenvalues. So actually eigenvectors and eigenvalues are the mathematical construct that must be computed from the covariance matrix in order to determine the principal components of the data set, right? As we discussed in the previous session, eigenvalues helps you to find out the principal components. Principal components are the new set of variables that are obtained from the initial set of variables. and they compress and possess most of the useful information that was scattered among the initial variables. So eigenvectors are those vectors when linear transformation is performed on them and their direction does not change. And eigenvalues simply denote these scalars of these respective eigenvectors, right? So uh, after calculating eigenvectors and eigenvalues, we can calculate the principal component, right? So once you have calculated these eigenvectors, these actually eigenvector matrix represent the principal components in the data set. So once you have calculated these eigenvectors and eigenvalues, all we have to do is order them in the descending order, organize all these eigenvectors in the descending order of their eigenvalues, right? Where eigenvector with the highest eigenvalue is the most significant and thus forms the first principal component. So if your matrix contains the multiple principal components, and after organize these eigenvectors, those are the principal components in the descending order of their eigenvalues. PC1 is the most significant and stores the maximum possible information. Then PC2 in that matrix is the second most significant principal component and stores the remaining maximum information, and so on. So if your data set contains 9,000 principal components for your original data set, you as a developer of the model can find out the best value of K, right? Only you can select the best K principal component. Those will provide the maximum information about your data set, right? So to finding the best value of K is a part of research. So by trying different values of principal component 2, 3, 4, 5, right? You can check your result with the help of tool and you can find the best value of K here. So first K principal component, those you have organized in the descending order of your eigenvalues, you can select for the final analysis, right? Then once you have found this first K principal component, those are important for your analysis only. Those are providing maximum information. You can reduce the dimension of the data set. So this is the last step in performing principal component analysis, which is the process to rearrange the original data with the final principal component, which represent the maximum and the most significant information of the data set. So how it is possible to reduce this dimension? So you will multiply this original data set with the first K principal component. You will multiply this original data set with the first K by K principal component matrix. So definitely, as you know, student, the mathematics of this matrix multiplication, if your matrix is of 2 by 4 matrix, your matrix is 2 by 4 matrix, and if you multiply this matrix with the 2 by 2 matrix, if you multiply this with the 2 by 2 matrix, right? So the resultant matrix will be 2 by 2 matrix, right? So here my first matrix will be your data set, which is of 2 by 4 matrix, 2 rows and 4 dimension, for example. Then your principal component matrix is 2 by 2 matrix, and when you multiply this data set with this K principal component matrix, then your resultant matrix will be 2 by 2 matrix, right? So without losing my original information here, without losing original information, we will get here the reduced representation of my data set. I hope, student, you are clear with this. So here is the example of the movie data set, right? Movie rating data set that contains rating from 700 plus users approximately, and assume 9,000 movies, and these 9,000 movies represent what features, right? So definitely it will be very complex task to design the model for this 9,000 movies features, right? So your principal component analysis will help you to reduce this feature. So after calculating the principal component, you can select only the 500. For example, 5 out of 9,000 principal component, only you can select the 400 principal component. Those will provide the maximum information about your original data set, and that you can multiply with the original data set to obtain the reduced representation of your data set, right? In the next session, I will cover the this implementation of this principal components analysis using Python. Right. So in short, just I will discuss here in this session what are the different libraries those are and methods those are available for performing this principal component analysis in the Python language. Right. So as usual, we need to import here the important methods, right? Inbuilt methods for the uh, principal component analysis. So this PCA is the inbuilt class defined under the sklearn.decomposition package. Right. So first step here is import this package PCA, which is defined under this sklearn.decomposition class, right? So from sklearn.decomposition, import PCA. After importing your required library, you can create the object of this class, right? So here PCA is the variable, small PCA is the variable, and this PCA is my inbuilt method, which is defined under this package decomposition package, and we need to pass here the number of components as a parameter. So for example, here too, so it is your job to identify the best value of this number of component by doing some survey, right? Then here, after creating the object of this PCA, you can fit your PCA model using this fit function. So PCA is my variable object. So PCA.fit will execute here the algorithm of principal component analysis. Those we discuss in these steps. Right. So this fit function will run the PCA algorithm on this data set X and will create the object of this method, which will have my final principal components and the eigenvalues and eigenvectors, right? So fit is the variable which will have the eigenvector and eigenvalue values and eigenvectors. Then after calculating these eigenvectors, so these are the inbuilt method. We are not using here mathematics to calculate the eigenvectors or covariance matrix. These are the ready-made methods available in my Python library, right? Scikit-learn library. So once you have calculated these eigenvalues and eigenvector with the help of fit function, we can print this. So fit dot explain underscore variance underscore ratio underscore. So explain underscore variance underscore ratio underscore. This is the inbuilt parameter, right? Define under this fit function to display the amount of variance explained by the each selected component. So explained variance is the amount of variance explained by the each selected component, and here explained variance ratio is the percentage of this variance explained by each selected component. Right. So that we can print here with the help of print function. Then also you can print the number of components and their values, right? Principal component with the help of this component underscore parameter. So this is the parameter. Component underscore is the inbuilt parameter that we can use to print this principal component, right? Which is defined under this fit function. Right. So here after executing this code, you will get this 2R what my variance means eigenvalues, right? You know that eigenvalue actually represent the variance between the features, right? So these are my two eigenvalues 0.92 and 0.05 for this X data set, right? And this is the eigenvector, right? This component parameter will return you the eigenvector. So these are the this is the eigenvector matrix for my given data set X. I hope student you are clear with this code. Now the demonstration of this PCA on Jupyter notebook I will explain in the next session. Thank you.